Yeah, g'day everyone. This is Nick from Electric Wheels Australia, aka Perth Electric Scooter Repairs in Perth, Western Australia. So there are a number of people trying to work out why they have problems with their motor, thinking it's the motor when it more than likely is the controller that's faulty. Now, in front of us is the controller for a Segway 9-bot. In this case, it's for the Max G30 series, and I think some of the G65s have the same controller. There's a new style of controller that come out, but the theory behind it is identical. And also, I'm going to show you, show you this controller as well. Okay, this is just a standard controller. I think it's from a brand called Dragon. I can't remember what it's from, but as you can see, it's got 2 rows of MOSFETs. Okay, and as you see, there's 2 lots of yellow too. Now these wires here, not the little skinny ones. Okay, not the little skinny ones. Where are they? Here. All right, not these little skinny ones. These go to what they call a hall sensor that's in the actual motor, and we won't talk about that right now because there is a video, will be a video on how to determine if your hall sensors are failing as well. So put that aside for now, and what I've got here, as I said, is a controller for a Segway 9-bot scooter. Now these 3, the blue, the brown and the yellow, okay, well in the case of other brands it's traditionally blue, green and yellow. Okay, now the power from the battery is connected, the battery is connected directly to the controller, in this case with this is a XT90. It's a lot larger than the XT60, which are the typical connectors that manufacturers connect their battery to their controller. Okay, now what I've got here is a multimeter that I'm going to show you how to use a multimeter. You can buy them for from I don't know, $8 or $9 on AliExpress. And what you're predominantly looking for, and as a point here, these cheapy multimeters I don't recommend connecting up to anything more than household mains. Like in Australia and Europe, etc., it's 240 volts. In America, I think it can be either 110 or 240. All right, don't ever hook it up to anything. Say, for example, a LCD TV, LED TV, anything like that, because there's voltage multipliers in there, and they could be 300 or 400 volts DC direct current. Okay, but your mains is alternating current. So if anyone that touches TVs are taking a risk, okay, when it comes to voltages, so don't do it. In the case of this multimeter, I don't know how much it costs, about $50, $60, something like that. But what is critical here, when you're testing controllers like this, you'll find that you'll need to go to resistance setting, or in this case, you've got a little omega sign. I'll just a little bit. Oh, that's more than a little bit. And on here you'll see that little omega sign, okay, which in the electrical world that means resistance and measured in ohms. Okay, so what I've done is I've switched it round to ohms. Now you'll notice that this icon and the sign, the SI sign, is not the same, okay, but the purpose here is that when you switch it around, you've got to go into the different modes. Okay, now there's your ohm. Okay, ohm, and it's M, which is a capital M for mega. All right, not little m for milli. And what you've got to do is change your mode to this icon here. Now this icon in the electronic world is for a diode, and what a diode does, it allows current to flow in one direction but not in the other direction. Okay, but when you put a voltage across it, like say for example, I don't know, 5 volts or something like that, it will show a little voltage across it around about the 0.4, 0.5, or in some cases up to 0.6 and 0.7. But in everyday use, you'll find it's around about the 0.4, 0.5 ohms, okay? But when with a multimeter you set it to the diode mode, it actually outputs, and you've got V, so you'd expect it to be a little ohm sign or something like that. It's not. What it does is it puts a little voltage, outputs a little voltage between these two terminals to check diodes, because you need a voltage across a diode to check to see if it's working or not. And if you want to learn further about diodes and about reverse bias and forward bias and breakdown voltages and all sorts of things like that, and the different versions of diodes, there's plenty of YouTube videos on diodes and how to understand how they work. All we're doing here is how to test the MOSFETs. Now MOSFETs, I'll show you on this one, which is a little bit easier to see, are these big components here. And you'll find MOSFETs in things like audio amplifiers as well, controllers of practically everything on the market that uses a controller, whether it's industrial controller for machinery, etc. They are fairly modern machinery. They do have metal oxide field effect transistors, because they can pump a lot of current through them, okay, which motors do need on say your electric scooter, your e-bike, etc. Now in the case of controllers, as you know, if you notice here, there's 6 of them, but there's and 6 here, and each half. So there's 2 controllers in here, okay? One for the front motor, one for the rear motor. This one is because the G series, the G30, has only got one motor on it. You'll only need one controller, meaning one board with one set of MOSFETs and 3 wires going to the motor, okay? Whilst this one has 3 and 3. Sometimes controllers may have dual power supply connections, so they may have 2, but internally on the battery, the 2 coming out of the battery, the big thick ones, okay, go into the controllers. If there's 2 separate controllers, internally the 2 positives are soldered together and the 2 negatives, so it doesn't matter which way you connect them up, okay? And the same from your power port where you plug your charger in. You may have 2 power ports going to the battery with skinnier wires. Makes no difference which way around you connect them as well. And they're usually, as I said, this is an XC, this is an XT90 connector. That's an XT60, and the XT30 is a little, about 2/3 the size of this one here. All right. Now, what does matter is which ones you connect these up to which motor. And in the case of some motors, you will need, there'll be like 1 or 2 of these. Oh, not that one. Where is it? Sing to me, Daddy. Yeah, no, that is it. That's it there. That goes to the hall sensors, like little they look like little transistors, but they're not. The field effect. They're hall sensors that detect magnetic changes in magnetic field. And this is actually an input from the motor to the controller, while these ones are output, because they've got to provide the power to the motor. Okay, and be aware, you never allow these low 5-volt voltage lines touch these high voltage, which can be, well, in this case, I think it's a 48-volt controller. This one is a 42-volt controller, but if you notice, it doesn't have the hall sensors. All right, it doesn't need it in this case. Now, how do we test this particular controller to see if it's working or not? Well, what I do is I connect up that's your negative or your common and your positive line, which is outputting a voltage. I actually haven't tested. Hang on, let me just check to see what the voltage is coming out of there. Okay, I just tested it, and the voltage coming out of here is 1.4 volts. Okay, now, so what I've done is I've connected up from the common to the battery connector on the controller. So this connector here is meant to go to the battery, and what I've done is the common I've connected up to the positive line, the red wire, okay, internally. Now what I'm going to do with the red one, from there to here, goes to these three the wires that go to the motor, and they are directly connected up to the MOSFETs. In this case, you'll see it's all covered in this rubbish stuff. And if you think you can fix that, basically, if you've got like 3 hours to dig it all out, because also in the potting, this potting material is underneath the board as well, which means you have to somehow dig it out enough to get the board out, but you just can't do it. The only way you can get that board out is cutting off the bottom, and then you can remove it all and go from there. And you have to remove that heatsink strip. All right, heatsink. You've got compounds, which are the pasty type, like toothpaste, and there's screws behind there to release. There's 3 screws there to release this plate from the box, and then you've also to remove that plate from those MOSFETs are the individual screws that you can see inside. To be honest, in this case, it'd be a waste of time. In this case, because they're open to air, it's a lot easier to repair. You just get to the solder joints underneath, and then you can remove the MOSFET to then replace it, if you can find the same or equivalent. Okay, now as I said, each of these cables going to the motor, these 3 cables here, has 2 or a pair of MOSFETs each, and that's the reason why there's 6. So whichever one you find is faulty, you would remove the 2 that are associated with the faulty line. Now be aware, if you can see, I'll just see it. All right, you'll notice that there's a little bit of white plastic there. It's an insulator, and you also got this stuff here, which is an insulator as well. Okay, that is to you got to have that insulator through the screw. Okay, it's a must. So when you put it back on again, don't lose those little washers. Okay, and you'll find that they are extremely difficult. Well, I say extremely difficult, but you've got to desolder the pins here. You've got there, and that one there, and then those 3 again. If we're assuming, because as you can see here, the blue wire is associated with those 2, and if you look underneath here and get this out of the way, then the green one is the next 2, and the yellow one is the next 2. And the same here, the blue one is associated with these 2 MOSFETs, the brown wires to do with those 2 MOSFETs, and the yellow to those 2 MOSFETs. All right. Now, it's highly likely to be a capacitor fault. Now, there's little drivers. See these little fellas? Again, I'll zoom in. Now, you see these little components underneath here. They are what they call drivers. They're low voltage, low power, but they tell the MOSFET what to do effectively. It's like a preamp type scenario. It's a low voltage, low power to drive the MOSFETs to power, provide the power, and it is extremely unlikely for those to fault it. But when you remove your MOSFETs, okay, and them, and you find they appear to be okay, then there's a possibility that the driver might be faulty, or one of the components associated with the with that group of MOSFETs. If it gets to that point, you're just wasting your time. So anyway, back to the basics again. So what I've done is I've connected up the negative, even though it's a red wire, it doesn't matter, you can see negative, the black end, to the positive. Then what I do is I connect up. Now if you notice here, this is all melted off because this overheated, this controller, okay, provided there was too much current going through, and then the plastic housing melted. Now these are molded, the plastic is molded to this, so it's not that simple. You basically have to snip it off. You can't just pull that sleeve out of the way to fix it. Okay, now I've connected up to the blue, and we're going to see what voltage we get out. Okay, so it's showing 0.474 volts. Now that tells me straight away that is a good output. Okay, so that means the blue is fine, even though it's melted. It just got a little bit too hot. Okay, currently it's fine. Maybe down the track, a little bit down the track, it may overheat. Who knows? Overheat, but destroy itself. And then we look at the brown one. Okay, now I'm hooking up the brown one. Okay, and then we look, and it's the same, 0.473. If it's within, if it said 0.48 or, which is not likely, but 0.476 or something like that, then it's fine, close enough. But I'll show you when it's not fine. So we're going to go to the yellow, like so, and you see straight away it's 0. Now 0 volts. When you have a short, in other words, your battery positive going to your negative, it'll show a short. It shows 0 volts because there's no resistance between the two. So in this case, what it suggests is that on the yellow MOSFETs, or the yellow line, the two MOSFETs associated, one or both have failed. Okay, so that would mean in this case, if you had, as I said, it's just not worthwhile repairing them, replacing them. I have cut out about 3 of these to get to the boards and whatnot to have a look. In theory, I could repair them, but I'll put it in a different box. And it's a bit of work for something that, like in Australia or America or England or Europe, people would just go out and buy a new one. And secondly, not only that, there's no guarantee provided on repaired boards like this, really. It may give, a month or something like that if they're generous, but generally speaking, a damaged equipment with a couple of new components, maybe the components might be under warranty, but not the rest of the board. So if it fails again, it proves to fail on a different line, that's not covered under warranty. You have to pay again. And considering the cost of repair of these things is about $100 an hour, Australian, or about 50 or 60 US dollars an hour, whatever it is in USA and Europe and UK. But in Australia, typically is about $100 an hour. And being potted, people say it's uneconomical to repair. Even in this case, it's a good chance that they would say it's uneconomical to repair, but in theory, it's a lot easier. You just check which one's faulty, and then you remove the both MOSFETs, check them, and then replace them. But you really need to see if you can get the same MOSFET or the equivalent of it, with similar specifications. Then you can slot them in with the same pin configuration. Means one's a gate, one's a drain, one's a source on the pins underneath, the 3 you see there. They have specific like an in, output, and a control line effectively. So yeah, so there you go. So if you're testing, it doesn't matter what brand or what model scooter or anything like that, you will find that they're all practically the same. Some may only have one controller, some may have dual controllers, or they have 2 boxes and one each would have a controller in it. So if, say for example, this was to the rear motor, all right, and your rear motor was making a funny type sound, don't necessarily assume that it's a bearing. Okay, there's a good chance that one of these lines is busted. Okay, and what some people do is that they swap these cables. Say that's for the front motor and it's a rear motor, and the rear motor is playing up. They can swap these 2 around. So this, instead of going to the front motor, they will go to the rear motor, and then you test the rear motor again, and if it's still making that funny sound, well then it could be the motor. But ideally you need a multimeter to check those lines. All right, now of course you do not have this in the scooter, or if you do, it's not connected to the battery. You just don't connect up to the battery. All right, I can do that myself. I can test it whilst it's in the scooter. I've also got a oscilloscope if I want to get really smart ass about it. Really clever in testing the output of these. to see if it's producing the pulse that's necessary, because each one of these lines, get this, not that, I'll just get these out of the way for now. Good. Right, turn that off. So each of these lines here, where's the yellow one, puts out a pulse from 0 up to, in this case, 42 volts for a little while, and then drops back down. But when it drops down, one of the other cables then starts to output. So there's a bit of an overlap, okay, a bit of an overlap to the next one, and then so on and so forth, because each one of these, oh, hang on, I'll get a motor. This is just added information. You don't necessarily need to know it, but it'll be worthwhile just to get a bit of a brief on the next bit. Won't be a moment. Okay, so here we got a motor. This part here with the shaft, okay, the axle, is called a stator, because actually it's stationary. You can't have this rotating because of the cable. The whole twist and then snap off. It doesn't work. But the outer part, well, here we go. Oh, these sudden thoughts or ideas of adding to the video disrupts it a bit. But this is the outer part that rotates, obviously, with the tyre. So this is called a rotor, as in rotates. The stator is stationary, and that of course sits into here. You've got one side, the axle going through there, and then the end cap, I call them end caps, like this one here. You could turn around and say it's a rotor end cap, okay? Allows you to pull out the stator, all right? You have to remove one side, and then now what you'll find is these are not magnetic, but these are actually permanent magnets inside. Okay, this is not. That's just part of the frame for the windings, the copper windings. It's just so that what you would do is that each coil would electrically turn it into a magnetic field. But as soon as the voltage from here, these three, is turned off or at 0, then there is no magnetic field generated. But what it does is that these cover 1/3 of the motor, and what it does is it associates these parts of the motor for the motor winding will turn into magnets, so to be a north south, south north, etc., or north and south and north and south. I'm not 100% sure on that right now, but the idea, I think it is, they alternate north south north south. And what it does is when it goes to go past these, all right, it forces the rotor to rotate. Now, if you know anything a little bit about motors, when you went to school or something like that, then you would have seen how the magnetic field changes and how it affects the rotation of a motor. But anyway, so here's your hall sensors I was talking about. Okay, so when we talk about the hall sensor connectors, right, like in this case here, this controller here does have a hall sensor wires, and as I said, this is an input, while these big ones are an output to the motor. Okay, look, she's stuck. And be careful, if you have pulled it apart, it's a mungle to pull apart. I will do a video on how to pull a motor apart, because it's not that easy, because when this is inside the rotor, the magnets really put a lot of force on it, stopping you trying to get the stator out of the motor. So here you've got your hall sensors, as you see here, okay, and you've got the 3 wires, and again they've got to be put in a certain way. Now that little slot that they're in, let me just zoom in a bit. Boop, come on. Right, now you don't really see it or wobbling around, but it's actually cut. Is the cuts on the side? What can I use to? All right, hang on. Oh, I'm wandering. The cuts on the side here are not straight down, they're angled back, okay? So this little fella here, which I've got somewhere, oh, here we go. Again, I'm all over the place. And I'll try and get you to see, there you go, you see on this side, it's angled, it's got a little, like a chisel, all right? And they got to go in a specific way. All right. And now whenever you look at part numbers, the top of the component, where is it? Can you see? Can we see? There. Okay. So in components, on components, whether it's MOSFETs, etc., the very top line is the part number. So 61A is what I was looking for. The bit underneath is usually like a batch or some other random number that's only relevant to the manufacturer. Okay, so you don't worry about it. Now, what happens when the hall sensors, all right, there's a hall sensor, imagine it's on one of these, goes past a magnet like so, it generates a, because the hall sensors are sensitive to magnetic field change. And of course, if the outside is rotating, it'll pick up the magnetic field changing on here, okay? And one way of testing these to make sure they work, and you can have your scooter on if you like, or you've got power, it's 5 volts, okay? 5 volts, where are we? Where's that controller again? Good. Oops, careful. So the hall sensor wires here, your red is your 5 volts, the black, of course, is your earth or common. And then you've got your 3 colours. You've got your blue, green and yellow. Now the blue, green and yellow are associated with these fellas here. So each one has a red wire going to it, and the red wire goes to there, and the common goes to each one as well. And then in the middle, all right, often in the middle, is the individual wires, the red, green and blue, the yellow, green and blue on the skinny wires going to each one of these. So in other words, each one of those that I mentioned, the green, blue and yellow, are associated with the hall sensors. So with the 5 volts going to it and the magnetic field goes past, it then sends a signal back, a pulse, okay, back to the controller, and the controller then knows exactly what the wheel is doing because of these magnets here. All right, it knows exactly that it's rotating, what speed and things like that. So these are quite smart. They've got a little chip inside them, a little IC to process that information, and it knows that when you twist the throttle on your handlebar, okay, it's not a controller, it's a throttle. All right, this is your controller. Some people call it power controller, but this is your controller that sits next to your battery in your battery compartment or in the stem. Just depends where the battery is. All right. Now, so when you turn your throttle, it sends a signal to the controller to say, hey, I want more power. Okay. And what the controller does do, it actually ascertains your speed and the information through the hall sensors, and it notes what speed you're doing, etc. You may have a preset speed or something like that, and then of course it feeds back to your display what speed you're doing. Okay, so yeah, it's quite clever. It's not the most clever system, but it's one of the clever. Some of them have Bluetooth capabilities, so you can see on your phone what your scooter's doing. But there's also in the batteries. I'll show you a battery now, just quickly. Okay, here's your connectors I was talking about, the XT60 and then the XT30. All right, there might be variations of the little ones and the big ones, but just be aware internally all the reds are connected together on the big one. All right, on the XT60 the reds are connected together and the blacks are connected, and then on the hall sensors, the power ports, all right, goes to your power port externally, are connected together internally, but often they're not internally connected to each other. So in other words, the XT60 is not connected wired to the power ports. All right. So here's your BMS, your battery management system board. Every single battery has them, okay, with your cells. So these aren't, I mean, lazily, I suppose, we call these batteries, but they're not, they're cells. All right, some is your AA batteries. They're really a cell, okay? Then there's your BMS, your battery management system board, and what it does is it controls the amount of, whether the cells have got to be charged up, or that when they get to the point of minimum discharge down to the lowest voltage that these cells can work at before they start to fail, etc., this will stop discharging. So when you're riding your scooter and you see your battery level dropping down, you know, your little voltmeter or whatever, it's reading off from here. And, well, from here, which is the same. And therefore, when it gets down to the minimum of that particular battery, then it'll shut down automatically. And then you've got to plug in your charger to then get the BMS to start charging them up again. And when it gets to their maximum voltage allowed, then the BMS will basically shut down, and then your battery charger light will go from red, which is charging, and back to green, which is not charging. Okay. I have done a series of videos on batteries, how they work, etc. So that's a separate entity, because really all I wanted to do is talk about controllers. But I thought it'd be a good idea just to briefly talk about these other bits and pieces in the video, but I didn't want to go over, because also in another video regarding Hall sensors is how to check these, so you make sure they're working without having to hook up a multimeter to it. But also things like checking the wiring, making sure that it is continuous from, say, from here through to here, and then to these connectors here, because sometimes the wires fracture. Now, if you've got a say a Segway 9-bot F series, like the F25, F30, F40, these cables here, these big fat ones, the three of them, they go to the motor at the front, because it's a front-driven scooter, and the cable comes from the controller in the deck and then goes down the fork and into the motor. Now, the fork has got plastic covers on it, and where that cable, you'll see the cable come up, all right, and then go into the plastic covers. At that exact point on the F series is a common fracture point, meaning that your scooter will turn on, your Segway will turn on, but nothing happens, because one of those, at least one of those wires has fractured, because that is a stress point, because the cable that is visible on the outside, okay, running up near the stem and back down to the fork, to the plastic covers, is flexing as you turn your steering, and the cable will flex like that. But at the point where it goes into the plastic cover is fixed. It's fixed. And so therefore there's a wiggle of the copper wire, and then eventually it snaps. Now, I've done about 4 or 5 F-series, so just be aware that when we talk about continuity in that scooter, that's where I'll be looking at. All right. Other scooters, often the failure is the point where, like in this case, where it comes out of the motor here. I've got a carbo where the thicker wires coming out here are somewhat bare, and they were touching, and I was getting this grinding slow. It's difficult. It's like what's the word for it? Electronic or electrical braking. Okay. And if you've got a Segway, this is a Segway 9-bot Max G30 wheel, okay, and you spin it, and it's a good everything's fine, it'll spin about 3 times, okay? But if you try and spin it by hand, this is turned off, it doesn't need to be turned on the scooter, and if you try to spin it and it does 1 rotation max or less, then you have got problems with one of these 3. Or that what's happened is that all of these have melted, they're touching each other, and that doesn't work too well, okay? Now, the other thing too, finally, I'm sorry to say finally, is that make sure that if you do replace these, you do not have these near, the connector here goes to the Hall sensors, okay? Make sure that when you all tuck it back into the scooter, that those Hall sensors are nowhere near these cables. Keep these separate away from them, because that can cause you to be forced to either replace the Hall sensors or replace the motor entirely, because 42 volts and 5 volts don't work together. That's about it. That's enough, I think, for this video. It's going on for 34 minutes. No doubt I've said too much and extended it unnecessarily, but I think that once you learn a little bit how these systems work, including about the motor, the Hall sensor, etc., then you'll find yourself a little bit more whizzy on it. but you must have a multimeter. Okay, and make sure it's got the, as I said, the diode mode as well. All right, bye for now.